Hey all, welcome back to my channel. In this video, we are going to understand what are port modes and what are the encapsulation protocol we use for VLAN determination. Then at last we will understand what is BTP, VLAN trunking protocol, and what are the few function of it and how to enable it. So let us understand what are ports mode. Port mode in a switch determine what type or how many types of VLAN can be transmit over that same port. So for example, we have two types of ports. First is access port, second is trunk port. Access port carries single VLAN information and it verifies VLAN information between switches. And these ports do not carry tagging information. So access port is a normal port where they share the VLAN information between each other. They do not transmit the data between so many VLANs. For example, if I have let's say two VLANs in both the switch, one, two, and one, and one, two, one, two. So we have two types of VLAN. Either first one is odd VLAN and second one is even VLAN. So with the access port, we will not be able to transmit the data for both the VLANs. We have to define that port to be trunk for utilizing multi-VLAN information transfer things. So these are the port modes. In trunk port, we carry multiple VLAN database between switches, and for that purpose, we utilize encapsulation protocols, which are ISL and .1q. Let's just understand what is ISL and .1q. So, let's understand what is a frame. As I have already teach what is a frame. Frame is a layer 2 messaging protocol way of sharing the data. Whenever a switch receive a data, it receive in terms of frame, which following a preamble and SFD, which are of 8 bytes together. So this is our frame. So in this is a normal frame which is called IEEE 8.2.3 Ether frame. When we are utilizing access port, which is having only one VLAN information, that time it utilized this Ether frame, where no discrimination in terms of tagging of VLAN. Everything is in a single VLAN. That way we use access port. If we are defining, we are segregating the broadcast domain via VLAN in switch. We have ports from different VLAN, and we want that single port to be transferred data for different VLAN. We utilize encapsulation protocols. So let's just understand what are encapsulation protocols. Encapsulation protocols do one thing: they add extra header in the ether frame. So let's just understand what is extra header. Yeah. So first, ISL. ISL is a inter-switch link. It's add 30 bytes of extra information on ether frame. It is very old and support only 1005 VLANs. So this is a old encapsulation protocol. We don't use it that often nowadays, as because for it is a 30 bytes information which we are adding in the ether frame. So which adds in such a way that, let's say this is our ether frame, 26 bytes it will add here, and 4 bytes it will add here. And so this is the ISL encapsulation protocol method. Now, on the other side, we have 8.21q, which is a multi-vendor supported protocol, encapsulation protocol. Let's say we have Arista switches or any other switches vendor. They utilize 8.21q encapsulation method for determination of multiple VLANs in the trunk port. and it support 4094 VLAN, which is much higher than your ISL supported VLAN. As well as it do one thing in the ether frame, it add in column of 2 bytes. Here it's totally 4 bytes where header information. So 4 bytes, understand how it is 4 bytes. So 4 byte header information, which is very smaller than ISL header information. Hence, we utilize 8.21q for multi-vendor as well as in general use. Now understand ISL and 8.21q differentiation. So in the header size, we utilize 26 bytes here. Here we utilize 4 bytes. In the trailer, we have no 0, but here we have 4, and it is only Cisco supported, Cisco proprietary, and here 8.21q is a multi-vendor. And the maximum VLAN in ISL is 1000, but 8.21q is 4094. Hence, 8.21q is much better than ISL. So all the vendors do give favoritism to this encapsulation protocol. Now, how to create VLAN in a switch? So this is the command to create VLAN in switch, and how to configure access port. First of all, we will log in to the global configuration mode of switch. Then we will write switch port. This is switch port mode access. Let's say you type in F01. This is the interface you log in. And then you will write switch port mode access. Now switch port no negotiate. So there are some negotiation methods which we will be using in DTP, which is dynamic trunking protocol later on. For now, just skip this command. And then we have so access VLAN 100. So this interface will be accessing these VLAN. This is a voice VLAN. This is access VLAN. Now we'll understand what is trunk port. Trunk port is, as I mentioned earlier, trunk port is a port which allow multiple VLAN data to be go through them, and it happened because of the encapsulation protocol which we have discussed, which add an extra header which consists of VLAN data into it. So this is how trunk port do transmit our data for multiple VLAN. And this is the command switch port mode trunk, switch port trunk encapsulation dot one q. So here we are defining, please use 8.2 encapsulation method. And now what are the trunks allowed? These are the trunk allowed. And native VLAN. Native VLAN is that VLAN whenever in a trunk port a untagged frame, which is IEEE 8.21.3 frame will come, it will travel via native VLAN. So this is how it happens. Now understand the main purpose of this video, which is VTP. VTP is a VLAN trunking protocol. It is a Cisco proprietary, and it's a layer 2 messaging protocol. When I say layer 2 messaging protocol, it means it use MAC addresses, it use layer 2 functionality, no IP addresses, and it allow for propagation of VLAN information. And in that, we do add, we delete, we rename VLANs. And if we have modes in this VTP, which are server, client, transport. And the messages which VTP share is summary advertisement, subset advertisement, and advertisement at last. Summary advertisement, all the messages I'll be discovering later on. And it use MAC address, which is multicast MAC addresses for determining or for advertising the VLAN information between the switches in a LAN environment or WAN environment. Let's just understand the modes. So we have three modes mainly in VTP, which are server, client, transparent. So what does a server do? Server create VLAN, add VLAN, delete VLAN, rename VLAN. These, and whatever VLAN created in server will be advertised to client. And but will not replicate here. It and the VLAN created in transparent will not be replicated to any of these switches. Client will inhale the information which is provided by server, and transparent mode will forward. It will not store the VLAN information. It will traverse. It will not and whatever VLAN we are creating in transparent, we will not be seeing replicated to other switches. So let's just understand the by definition. Server on this mode, switches can create, delete VLAN, and VLAN created on this mode replicate automatically on other client switches within management domain. And this whole thing happen in a management domain, and, and we can specify a name to it. Let's say Cisco engineering or whatever name we would like to give to that VTP environment or domain. And client is another type of mode where we cannot create or delete VLAN. We can only receive or forward the advertisement from server switches. So server switch is the one whose VLAN information shared to everybody, but it will not replicate it on transparent mode, but it replicated on client mode. So this is how the BTP modes. And let's understand last mode, which is transparent. Switches can create VLAN, which does not replicate on other switches within management domain. So this is another type of mode of BTP where whatever VLAN we create here, it does not replicate. It will be there for transparent mode. So mainly we use it for management purpose. Let us understand about the messages, how VTP creates, how it synchronize with other switches. Every 5 minutes, it sends a summary advertisement, which is like which is like, hey, this is the VLAN we have added, or this is the information. And then if switch add any other, so this happen in three ways. If it first of all it happen every 5 minutes, or if there is any change, or if it wants to share the switch about the current domain of BTP. In these three cases, it send a summary advertisement to the switch. Let's say we have this to switch, it will send summary advertisement. Once it sends a summary advertisement, the other switch will be asking for the detailed information of these changes. Then it will send summary request. Summary request. And so here's the second point. It's a summary request. After asking for detailed information like if the switch has been reset or VTP name change, what happened, or do you have anything for a higher revision number? So this is what the other switch asks for switch one. Then switch one what do after getting the summary request, it will transfer the actual data, which is subset advertisement, and this contain a list of VLAN information and what are the several changes it has been which has been changed, and this all happen in a revision concept with the revision concept. So let's just understand what is revision concept. See, revision is, see, whenever any let's say we have the server switch and we have client and here client. So let's say I created VLAN 10 here, and that time revision number was 30. Then I do VLAN 20, then I add VLAN 20 also. And see, this is server, this is client switch. Once I create VLAN 10, all will be having a revision number of 30. Revision number of 30. But once I add VLAN 20 here, the revision number will be increased by 1, and everyone will get a all the messages, summary advertisement, summary request, subset advertisement in the same way what I explained, and they all will be refreshed with the new revision number, which is 31. So now revision number will be 31. And what's the problem which we were facing? Why lots of network engineers face in this BTP is, let's say if I add something, some other switch here, and which has an existing revision number, let's say 500. In that way, this will switch will override this revision number, and the whole data which is VLAN 10 and VLAN 20 was there. It all will be drained off. It all will be goes wrong. Only the switch which is having revision number 500, which is having VLAN, let's say 35, will be copied over the whole network topology, and that way VTP gets failed. So revision number plays a very important role here. So whenever in a network topology there is a change with higher revision number configuration, number of VTP, then the whole server data VLAN list got exchanged, and all the configuration get failed. And this is the basic commands to enable VTP. As I told, VTP modes are three: server, client, and transparent. So we can utilize any of the mode in the any topology, and we have to specify the VTP domain name for the server switch. What is the name of the VTP domain? Then we can set the password for it, and we can define the version, VTP version, and VTP pruning. Pruning is like whenever we have a switch, end switches, like your access switches, and we have some end port, end node on it, and they are utilizing some VLAN, but there is no traffic going here, and that way we are utilizing pruning. So let's just understand with a practical. So in the practical, I have taken four switches. One of them is server, then transparent. This one is transparent. Then it is client, and then it is client. So server, I have created VLAN 10 and 20. In transparent, I have created VLAN 30 and 40. From your understanding, what do you think a who is having a VLAN information of 10 and 20? Obviously, the client switches, these two switches. We will check. And do you think this VLAN information will be there in the client switches? No, because the transparent switch will not replicate forward its own created VLAN. Unlike server do that. Server advertise their VLAN information through VTP to all the client switches, as well as client switches do replicate the information which they receive from server to other client switches, as well as the transparent switches. Transparent switches do not digest the server VLAN information, but rather they forward it. So let's just understand from uh, practically, or how in the Cisco packet tracer I have created this network topology. So this is our server switch. Let's see how many. Oh, let's just see the show VLAN brief. How, so in as you can see, we have 10 and 20 VLAN here. Okay, let's just see on this client switch. Do we have these VLAN? Show VLAN brief. Yeah, we do have. You can also see that show VTP status. I can see this switch is a client switch on this domain name Cisco, and pruning is disabled. And what are the VLANs existed here? Seven, out of which five are default and two we have created in server switch. So this VLAN which you've seen here are not created here, rather it created here. I can also do one thing. I can go to the configuration mode and create a VLAN 60 exit. Let's see if this VLAN 60 got replicated here or not. Show VLAN brief. Yeah, the 60 has come over here. But according to you, now this is client switch have the information from server switch about the VLAN information. Let's just see whether this transparent switch have those detail or not. According to the concept, it should not be having the server switch VLAN information. Yeah, it doesn't have 10, 20, 60 because it's a transparent switch. It only forward the information of VLAN from server switch to the client switch, not hold it or not digest it. So it has rather its own VLAN information, which it do management stuff. So do you think now this transparent switch is not holding the information, but it is advertising the VLAN information? In that way, we should have on this our server switch, we should have our server VLAN information. Let's just see. Enable show VLAN brief. Yeah. Now this switch has about all the VLAN information from server switches. So this is the concept how VTP runs in a network topology. How it has a layer 2 messaging protocol. It has modes, three modes: server, client, and transparent. And it has different commands. I can show you the commands also how to enable this. So this is the command which you will be running on these switches: VTP mode server, VTP mode client, transparent, VTP domain, VTP password, VTP version, VTP pruning. And before all this, you can also also have to do one more command which is switchboard mode trunk. So that command also needs to be done here. So I hope you understood VTP. So for more such videos, please do like subscribe my channel. Thank you.